Yeah. So we can get started whenever you're ready, Tim.
Okay. All right. Thanks everyone for showing up on this Saturday evening. Got Josh here from Kabam and myself. We're going to give a presentation on how to make a stable mobile video game. For those of you who don't know, Kabam is a mobile game developer. We have our largest studio here in Vancouver. Some of the games that we're known for are Shop Titans, Transformers Forged to Fight, and Disney in Reverse, which is actually available in Canada. It's not available worldwide yet. And the main game we're known for is Marvel Contest of Champions, which is one of the most successful mobile titles of all time. It's been out for 7 years and has made billions of dollars. So huge success. If you have any questions as the presentation is going on, feel free to put them in the chat. Josh can ping me if you have questions. We'll also leave some time at the end for any other kind of questions. A little bit about myself. I'm a senior technical director at Kabam. I've been at Kabam for just over 2 years, and the title I've primarily worked on is Marvel Realm of Champions. So if you hear me talking about MROC, that is me talking about Marvel Realm of Champions. If I'm using some sort of acronym you're not familiar with, please let me know. As with most tech companies, you tend to forget that you're talking in acronyms that people outside the company don't know. Prior to Kabam, I've worked at Capcom and Blue Castle Games on EA on various PC and console titles. So this was a bit of a learning experience for me working on Realm of Champions. It was my first mobile title, so a lot of this stuff that I'm talking to today was things that I kind of had to learn in the last couple of years. So it was kind of an interesting thing for me. First, why do we care about stability? Primarily because our customers care about stability. It's not fun to play a game if it doesn't work well. And if your customers are unhappy, they're going to complain. And we end up with unhappy customers and poor ratings. It's obviously bad for the business. So this is something we don't want to have happen in our games. And there's actually, it's not unusual. We actually have conversations in the company about stability and why we care about it, because there's usually a bit of tension between adding new features and, working on things to make the game more stable. So, it's important, particularly on the technical side, you're advocating to making this game stable because it's something that the customers tend to really appreciate. What is stability in a mobile game? Typically, the main things that people care about are crashes, which is fairly obvious. So the game stops working, a hang, so it freezes. They can't continue playing. The other ones that tend to have an impact on stability, and at least in the Kabam world, we consider part of stability is frame rate. We make a lot of games that are they're action games, so they're very twitch sensitive. So if the frame rate is going up and down or is consistently low, it makes it hard for people to play our games or puts them at a significant disadvantage. So users are very unhappy about that. Also battery usage as well. It's a mobile game. If you can't play for more than 30 minutes unless you're plugged into your charging adapter, that's an issue as well. So that's something that we pay a fair bit of attention to. So all those together is, if someone says, hey, is your game, how stable is your game? These are the kind of factors that play into it at Kabam. Stability. It's an ongoing process. People say, hey, is the game stable? But you're never going to have a game that is 100% stable unless it's absolutely trivial game. And, we don't make those kind of games. Well, nobody does these days. So even if you stopped, typically your game, you're always adding new features to it. Most games are live games, so you never get to a place where the game is done until the game is shut down. So you're always adding new features. And when you're adding new features, there's new bugs that go in. So that impacts your stability. Even if you are not making changes in your code base, all of our games and most games have a server component to them. So they will be organizing live events and things like that. They will be changing rewards and payouts, and all those things can impact whether your game is stable or not. And even if you get to the stage where, hey, you're done your game, and you're not changing anything, the world continues to change around you. If you have a phone, and everyone does these days, you know that there's always operating system upgrades. The new iOS versions are coming out. There are network upgrades. So in this case, that could mean your carrier. So, obviously in Canada, so if you have TELUS or Shaw, whether they're doing, the one that happened recently is IPv6 upgrades on some of the carriers. That happened a few years ago. So that can introduce problems. And there are also changing first-party requirements. So in the mobile gaming world, the first parties, we call them Apple and Google. They are the publishers, and they can come up with new requirements. Things like, the new privacy enhancements that Apple came out with asking about, basically approval to track and things like that. So they're always introducing new things that can cause issues. So even if your game is not changing and your code is not changing, the world is changing around you, and those can also introduce stability issues. When one of the questions we tend to get asked is like, hey, is the game stable? It's not a simple yes or no answer to like that. Players can have drastically different experiences. As someone once said to me, asking me whether the game is stable is like, imagine you're coming on looking at the planet Earth and saying, what's the temperature, right? You say, well, the average temperature is 15 degrees. That's correct, but that doesn't really represent the different experiences that people are having. The average temperature is 15 degrees. People can be freezing in the Arctic. People will be sweltering at the equator. Same kind of thing for games. You can say, hey, yes, our game is pretty stable, our average crash rate is low and things like that. But people can have drastically different experiences depending on a whole bunch of things. Who their carrier is, what kind of device you're using, whether it's Android or iOS, or whether it's a high-end or low-end device, what country they're playing from, because that could impact which server they're talking to, or which language they're using, the time of day. Servers can get busier depending upon the time of day, which game mode you're playing. Some game modes can be more stable than others. What sort of live events are going on? For example, we had an issue in the game MRock that I most recently worked on. We had a problem in our code that when the live events turned on, is we were caching data about the events status. And so when the live events turned off or on, our screens cached the data about that. And then when they actually tried to access that data, if that event had been turned off. So what would happen is they go into the screen when the event was active, let's say at 10 a.m., at 10:01, that event turned off, and then we try to access that data and our game was crashed because there was an expectation there that this event status had maintained the same over the length of the screen. Obviously that wasn't really true. So we had these huge crash spikes, whenever our events turned off and on. So if you played during those times, you could have a really negative experience. And it wasn't something we should have anticipated, but we didn't. Also your play style, what you're playing, how often you're hammering on the buttons, location, there's a tons of factors. So people can say, hey, the game is super stable. The person playing beside you can have a drastically different experience. And this can kind of come down to a lot of the stats we collect are like, what is the average experience out there? Like, what is their average frame rate? How often are we crashing on average? And that stuff is super useful, but can also hide a lot of details. We say on average, the game is not crashing. That's fine. But if you're playing on a particularly Android device that's crashing a lot, you may be having a terrible experience. And that means you're not going to play your game and you're going to stop, purchasing things, which is not what we want. So you really have to pay attention to the details as well. Okay, so you want to make a stable game. Where do you start? Unsurprisingly, you need to start it. It's much easier to start at the beginning of the project. If you start and focus on stability from the beginning, it's much easier and better place to be in than trying to make your game and then worry about stability at the end. It is really hard to dig yourself out of a hole like that. I have been on games in the past where you're in a situation where you have the game and it's function complete, and then you've got stability issues, and they say, well, how long before we're at an acceptable level of stability to launch or ship the game? And the answer is, a lot of times it's really hard to tell. You don't know, because when you're trying to dig through all those stability problems, a lot of these problems hide each other. So you fix one problem, and until you fix that problem, you don't know what the next problem is. So it's like, the term is like peeling an onion. So it's really hard to say, hey, it's going to take us, 1 day or 1 week or 1 month or 1 year to fix all these problems. All you can typically do is fix them in order until you uncover the next one. So that can be a really stressful situation to be in when, the people in the studio are saying, when are we going to launch? Are we ready to launch? Why, how much more stability work do we have to do? And the answer is, we don't know. We're fixing the issues as we find them. So if you start from day one, you track it as you go through, you don't have this huge overhang of stability work at the end. You end up in a much better place. It's way less stable, and it's more predictable for the business as well. So you want to start from day one. When you're actually making a stable game, I'm going to start talking about what we do in the production phase. So typically in game development, you have some sort of concept phase where you figure out what game we're going to make. Usually there is some sort of pre-production or prototyping phase where you're trying to figure out, what it is about your game that's fun, come out and finalize the design. Once that's sorted out, is you enter your production phase, and that's really where you are doing the majority of the work to make your game. So you know what you're doing, you've got the design sorted out, you have all your technical things solved, major technical questions solved, and you're in production. You're actually building the code, you're making the assets. So in the production phase, things you want to do and have a stable game, and we'll do and talk to them about it. Things that are super helpful are unit tests, continuous integration, continuous deployment called CI/CD, automated tests, network testing, load testing, and QA. So we'll talk about those in a bit more detail. So unit tests, these are smaller, discrete tests on your individual code units. Determine whether they're broken or working as expected. Usually they're the first thing that tells you if you've broken something, and you want to have it there to make sure you're not building your code on an unstable base. Typically at Kabam, we focus our unit testing on the shared underlying libraries, and that's to make sure that the pieces that we are building on are stable. We don't have 100% coverage for all of our code for unit tests, but the stuff that is used most frequently we do, and we tend to focus on the areas that are easier to do unit tests on. So some of the higher level, like rendering functions or AI functions, it is much harder to tell, is that shader working correctly? Is that AI function working correctly? It's much easier if you have things like math or memory or file access functions, or whether they're working correctly. So we start with unit tests, and then as we add the code on it, we add the unit tests, and if the tests fail, that gives us an indication that we've broken something in the underlying code. Next, for the continuous integration and continuous delivery, for those of you who don't know, this basically consists, at least in the Kabam world and most places, is automated builds. So as people check code in, an automated build goes into the source repository, an automated build kicks that off. Once the build is finished, that build gets distributed. In this case, it gets uploaded to a system called TestFlight, where all the people on our team can download the game and play it. And then there's a bunch of automated tests that go along with that. So this is just a quick capture of our automated build system. So after you check in, there are no builds. You can see at the top level, this project, in this case, this is the Realm game on the main branch. There are currently no builds running. There are currently no builds queued, and you can have a history of the previous builds that have happened in the past. There are many different build targets that we use. There are what we call submission builds, and those are the ones that actually get submitted to the publishers. Then there are other builds. We have builds that are specifically for debugging, and those have additional debug libraries in there. they can allow you to jump through game modes. They can, choose characters, give you extra abilities, all that kind of stuff. And that's typically used by QA, so they don't have to play the game linearly. There's also additional information in there, so you can tell what server you're connecting to and all sorts of information that help them give us information to fix bugs. Then there are other builds as well, such as profiling builds that allow us to collect information on how the build is performing through profilers. So we got this. This is a good situation. All of our builds are green. If you look a bit more back in the build history, we've got some broken builds here. So this is bad when this happens. So somebody's checked something in. This has broken the builds. Ideally, your CI/CD system should prevent this happening. There are some ones out there where they actually check each change individually before it goes in. The current way we have our system configured is it batches up. So if you happen to check in, it can actually break the build for everybody, as opposed to actually checking your individual change and backing it out if it's bad. But overall, these CI/CD systems are super important when you're working on larger teams. It allows you to make sure you've got a stable place for your builds and tell everyone when they break. So in a situation like this, the build gets broken. You can go and take a look on the web page. It tells you the status. We also have a bunch of other ways of notifying. So you get an email. I've got a bunch of Slack channels that tell you when you've broken the build. So if you've checked something and broken the build, expect you're going to get pinged about it very quickly. So you've got your builds working. Once we get a successful build, the next step is automated testing. So we have a whole bunch of automated tests that we run to find bugs. The tests are manually created. We have a test engineer that goes through and we discuss the major functional paths of the game, and they write a bunch of scripts and tests to do that. And in this case, you can see in this screen, so this is a summary page for all the automated tests that have been run recently. On the left-hand side, there's a list of devices. So unsurprisingly, or maybe surprisingly, the game behaves differently on different devices, and it can work on some devices and not on others. On the top, across the top, there are a list of CL numbers. So those are consecutive builds. So in this case, it's a matrix where you can see how did this build with this CL number run on this device. And if you take a look at this one, kind of in the middle at the bottom, there is a series of 3 red dots. So when I look at this, it's on the iPhone 8 Plus line. I go, wow, it looks like we did something that broke this build only for the iPhone 8 Plus for those 3 builds. When I'm sitting there as a technical director, I would look at this and I'd say, hey, can someone go take a look on this and take a look on the iPhone 8 Plus and see what's happening with the game. So there's something specific about that. So having things like this really allow us to make sure the game is continually working in the major areas across a broad range of devices. This is the detailed screen. I don't know how much of you are going to be able to see, but this is basically, again, the CL numbers are on the leftist side, but this, rather than just showing an individual test, this shows all the tests that are running. And we have a huge number of tests that run on the games. Some of them are pure functional tests. Other ones are tests that actually collect data about memory usage and things like that. So one of the things that can really impact the stability of the game is memory usage. A lot of the devices, particularly on the low end, have restricted amounts of memory, and if we take up too much memory, we will crash or get killed by the operating system. So what we tend to do is these tests run. We collect information about how much memory the game is using while it's running, and then we graph that in various different places. A typical thing is what happened is an artist will check in an art asset, and they may not pay attention to how large it is. So we may have a huge 4K by 4K texture come in for somebody's eyeball or something like that no one's ever going to see. That'll blow out our memory usage and really impact the stability. So those are things we track through these kind of tests as well. This is an example of an automated testing break. Here you can see on the rightmost CL, somebody has checked something in that has basically broken the game for almost all the devices. The fact that it isn't broken for all devices kind of leads me to expect that this is probably a memory issue where it's kind of blown up for everything except for the the super high-end devices, or maybe, hard to say what it was in this one. I can't remember. But this is an example where someone's broken the build for almost everybody. And this is another kind of example of some more different kinds of automated tests we run. In this one of the things that we can do is automated tests that are expected to fail. So in the middle line of this test, we have what we call our low-end memory test. So what we do is we actually play consecutive games, and we do this on some of the lower end devices. And for us, a lower end device it's usually an expensive device. It has a slower processor and less memory. So we actually run the game and we play consecutive matches in our game until it crashes, and then we track that number. So we're always curious to see how many games can we play on a device until we crash. And then we go back and we usually talk with our producers about that. And we say, how many games, how many games do you think the people care about, right? Do they want to be able to play 15 games consecutively, 30 games consecutively, 100 games consecutively? Usually the answer comes back is they want to be able to play the game an infinite number of times. And our answer is, yeah, we can do that, but it's super expensive for us to track down every single memory leak and every single issue that allows you to do this. And we'll say, how about 25 games? And usually we come to some sort of negotiated agreement around that. Once the game actually goes live, we can actually track and see how many games people are playing. And if they're running into those limits, we'll try and work to boost them up. But we want to spend our time fixing problems that people are encountering in real life. Other things we do, network testing. Network conditions for mobile games can be very challenging. People can play games pretty much anywhere. There are varying network conditions across the world, from super high end to very sketchy connections. And it also can depend where people are playing from, whether they're playing in the basement underground garage or whether they're sitting, at home on their local Wi-Fi. So a lot of the work that we do is obviously in the office, and that has great network conditions, but we can't depend upon that in the real world. So we use a variety of network emulation software and hardware to emulate poor network conditions. And we do that during the development process because it can be really expensive to fix those kind of issues later on. Playing on networks that drop connections or have high latency tend to introduce problems that can be hard to find, and they can be very transient depending on the network conditions, so they can be hard to reproduce. If you say, hey, we're going to find and fix those all in the last week or month, you're going to have a hard time. It can take a long time to really track some of those down, so you need to start on that stuff earlier. So we run and test on a variety of network conditions. Other things we do during production is server and load testing. So all of our games have got a server component on them. And a lot of these issues, when you actually go to worldwide launch, they can be hard to find. The servers can behave differently under load. Issues that can come up, particularly around uses of shared resources and locks, may only show up when your servers are under high load. So everything works fine when you're at 25% usage. When you hit 75 or 80 or 90% usage, there can be bugs that show up, and they can be very subtle along the time. And they only show up under high load, and they can be timing related, and tracking that stuff down and fixing it again takes a lot of time. So that's not something you want to leave to the end. One of the issues you kind of struggle with is it's really hard to get a simulated server load that reflects the real world. So typically we're guessing when we're in production. And once we go live, we can actually usually collect server usage data and build technology to replay that back. But before we're live, we're guessing. It's never 100% correct. Sometimes it's really incorrect. We make really bad assumptions or guesses about it. One of the things we can do to deal with that is we typically, when we go launch, is we over provision the number of servers. So we think how many servers we're going to use, and whether we at least double it, but sometimes we'll actually go 5 times or maybe even 10 times. That's a great short-term solution because all your servers are going to be under low load. That's typically not a great long-term solution because you're paying for those servers, so it's expensive. But we start off, it's a great short-term solution to make sure you're not having any problems. And then you can collect data on your live server usage and make some better judgments. QA. QA is also super helpful. You can't do everything with automated testing. Typically, full coverage is hard in automated tests, particularly if you're writing them manually. So you don't have full coverage, usually just the main areas. It also tends to lag behind new features. As the new features come online, if they're changing all the time, it can be hard to write tests because you're breaking the test with the changing functionality. People are great at figuring that stuff out and understanding, is this a real bug or is this just changed functionality? We also need test coverage that plays like real players. Automated test doesn't really do that. With our QA groups, we tend to have them run a mix of what we call prescriptive play, i.e., run the same test thing over and over again every day, so we can make sure we're not breaking things, and free play. There's one of the things our QA is also great at is what we call them SkyTrain tests, and this was simply because we noticed that one of our QA people was actually logging the majority of their bugs in the morning and the evening, and that's because they rode the SkyTrain in and they were actually testing on the SkyTrain, which is actually a great test for us. You're being handed off from various cell towers, you're losing connections in the tunnels, or you used to be able anyways, and they had a variety of speeds. So it was super effective, and it got to the point where sometimes we would actually send people out, can you go ride the SkyTrain for a while during the day and play the game? It was the easiest way to get a huge variety of network conditions for us to test, real world network conditions. There are a bunch of things that are going on these days in terms of QA testing that people are doing with machine learning, where they're trying to, obviously teach your computer to play the game. There's some exciting advances in that. It's not quite there yet, but you can kind of see that playing a bigger role perhaps going forward. So we've done this production phase, we've built the game, we've been doing all this great testing on the way, and now our game is actually ready to go live. Like, what do we do next? So in an ideal world, what you want to do is you don't want to flip the switch and go live to everyone at once. So you want to do stage publishing, either by a country basis. So for instance, you can play Disney Mirrorverse in Canada right now. It's one of the, I believe, 6 countries in the world that you can currently play Disney Mirrorverse. Or you can actually have beta sign up where you get users who are interested in playing a game and you sign them up and deliver it to them directly. What you're trying to do is get information about the game before you've got, potentially billions of people playing your game. And when you sign people up, you want a smaller audience, and you're trying to usually get some sort of representative sample of people who will be playing your game. Things you want to consider are like a device mix. The device mixes change drastically in the different countries across the world. What's the devices that are popular in North America and Europe and Asia are drastically different. A variety of parts of the world with different network infrastructure, some that are super fast, some that are perhaps slow. Localization. Countries, if you're going to support different languages, you probably want a mix of those. Particularly if you're supporting some languages that are drastically different from Western languages. If you have some sort of Arabic or something like that that has the right to left, you probably want something like that in there as well. Different currencies, areas of the world with different historical spending trends. Places like United States and Europe, and some parts of Asia can be very high spenders versus other parts of the world that aren't. And also server regions. This can be very important if you have a multiplayer game. Where and how are you going to group all your different servers? In the case of MRock, we had 3 server regions. We had a European, we had a Americas, and then we have an Asian. And when you're rolling the game out, particularly not worldwide, you want to say, okay, are we going to pick areas that are all similar so we can have all of our players playing on a local server where it's fast, but that usually does not meet the criteria for all the other areas where you have these devices. So if you're going to have them on all the one server and they're coming from around the world, people in North America playing on an Asian server could have a terrible experience due to network lag. Versus if you split them up and you have a North American and an Asian server, they may not have enough people to play with, and it's also going to be a not great launch experience for them. So there's usually a huge number of factors that play in here. But what you're trying to do is get a variety of experience and collect data, so you're confident that when you go live, you've kind of solved all these problems. Telemetry. When your game goes live, you need to collect telemetry. So if you're not familiar with it, telemetry is basically automated data collection from the game. I cannot overstate how important this is. Your game is out there, it's going live. How's it doing? Is it stable? Is it crashing? Who knows? Without any telemetry, it's going to be really hard for you to tell. So you need some sort of system, and you can either buy them or build them yourselves, which collects data. Typically, the kind of data we collect is information about, the client. What sort of device are they running on? How fast is the game running? What sort of memory is on there? Is the game crashing? We also have telemetry on our servers in terms of how loaded are they? What sort of transactions are going through them? We also collect telemetry information on the networks. How, what's your ping to the servers? What is your round trip time? What's your bandwidth? Those kind of things. There are also first-party connections with our game with Apple and Google. So for things like login servers, we also connect to those kind of servers. So we collect as much telemetry as we can. So what we're trying to do is collect all this information so we can figure out what's happening in our game. Are people playing it? Is it crashing? Is it running fast? We collect all this data and we transmit it back to our server through a RESTful connection. That data then gets stored in a database. We actually use BigQuery, but you can use any sort of large database that you want. And then we actually run all sorts of reports on it. And typically, a lot of the reports are run through Tableau, which is a data reporting tool, but we also, people write SQL queries. We import into Excel and slice and dice it. One of the things that we notice is that we spend a lot of time on this, and we're usually tweaking it, and we're almost always writing new reports. Either we have to dig into more data to find out what's happening in a specific instance of a problem, or the data is such a large volume that we have to summarize it so we don't get overwhelmed or whatnot. But there's a huge variety of reports we're doing. It's something we're always doing, and we have data analysts who kind of specialize in this world to help us as well. One of the most important things as engineers that we get back from our telemetry is client crash reporting. So in this case, if the game you're running on your phone crashes, what we do is we try and catch that exception or that signal. And what we'll do is we'll collect a call stack and the various logs, and then we will report it back to the server. If we actually don't have a network connection at that point, which can happen somewhat regularly if the game is crashing, we actually cache that information locally. And then the next time the player runs that game, we will upload that data. This crash data is super valuable. And we actually collect it both from our development systems and from our live production systems. It's super helpful that we have the same system. So as we're going through development, we can tune and fix any bugs in the system, and then it's ready when we're ready to go live. And I'll go through and we'll actually take a look at some of the things that we collect here. So one of the things that I look at, usually when I come in the morning, this is our overall crash reporting information. And this is usually the first thing that I look at. So this is on our game. This is our crash per login. And as you can see, it's separated by the Android and iPhone, and this information comes out per day. And this is kind of the first thing I look at, see how we're doing. This is a similar kind of thing. Except this is crash per match versus the login. So this is, in this case, we're running between 4 and 5%, or 0.9%. So the 0.9 means that For every 100 games you play, they're crashing 0.9 of a time. This kind of is a good summary of our overall client game experience, and this is how I start my morning. One of the things that you'll notice here, well, I don't have the description here, but the blue line is Android, the orange line is iOS. Historically, the crash rates for iOS are lower than Android, and that's because the iOS device world is much more constrained. There are fewer varieties of iOS devices. The Android device world is the big Wild West. There are thousands of devices, and they're all different, and they all have slightly different hardware and software capabilities. So it's much harder to keep the game stable in the Android world than it is in the iOS world. So once we've got that crash summary at the high level, I'll start digging down. So we get more detailed information. Are the crashes happening on the Android or the iPhone? Are they exceptions that are happening in the game, or signals that are coming from the kernel that we've done something bad? So we'll take a look at that. We've got the high level crash things, get some more detailed data. And then I'll get the actual details about the crash. So this is a table we'll have, and it will basically break down the crashes, and it groups them by call stack. So in this case, we've got a call stack at the top that's occurring 23.73% of the time, almost 24% of the time the game crashes. It's got that top line in the call stack. So someone is doing something with a material that is bad when they're resetting color. So what happens at this point is we usually go through these, we take a look at the most frequently occurring ones, and then we will send that out to the engineering team for fixes. So what happens is we take a look at these bugs, the technical leads will go through, we will triage them, we'll assign them to the person that we think is best suitable to fix them. As an engineer, you'll get one of these devices on your table, or one of these bugs in your bin. So we use Jira. There are a bunch of other bug tracking. So if someone enters a Jira issue for this bug, if you're lucky, you've got this bug. It's obvious what the problem is due to the call stacks or the logs, and you can reproduce it. You can put a fix in there, and because you can reproduce it, you can fix it. You can confirm that your fix works. If you're unlucky, the bug may not be reproducible, or it may not be obvious what the cause is from the call stacks. Maybe it's not reproducible because it's device specific. It only occurs on certain carriers. Maybe the reproduction rate is real low. Some of the bugs we chase, only occur, once a day or once per week. And that's over tens of thousands of users. So the chances of you being that person being able to reproduce that are super low. So when that happens, we have a variety of different things we can do. We can try and get the device in. Typically, we will troll through our crash database and try and say, is this only happening on certain devices? Is there anything unique about this? Is it only happening in certain parts of the world? That kind of stuff. If we can't figure it out, if we have some guesses about what the problem is, we may do a speculative fix in that case where, hey, we know this is going to make the problem worse, but we will try and do a fix in, and then we'll publish the build and see if it makes it go away. If we can't figure it out at all, a lot of times we will just place additional logging in the build to try and narrow down what the problem is. That's usually fine for lower frequency crashes. We'll just push that in the build and wait for the next one to go out. If it's a big crash, we may publish a build specifically with additional logging because we can't wait to fix that one. So it depends upon how often it's happening. One of the things that I mentioned earlier is we can't depend upon the averages for these bugs. And what this slide actually shows, it's kind of hard to read. But this is a list of devices on the left-hand side. And there are two bars here. The dark blue bar is the crashes per match. So that's basically how often is the game crashing relatively for each match. And the light blue bar is actually how many absolute number of crashes have happened on this device. So if we were to take a look at the top devices, those devices have got a high crash rate percentage. So they are crashing about 30% of the time, or even higher, 40% of the time for each match. So these are very crashy devices for us. Versus if you take a look at a device lower down where that has a very short dark blue line, that's not crashing very often. It has a high, if it has a high number of absolute crashes, the light blue line, that's because it's a popular device. So it's some sort of Samsung device or iPad or iPhone device that's super popular. And this kind of goes to show you that what I was talking about earlier is you can't depend upon the averages. So on average, people may be having a great experience with a low crash rate. But if you happen to own one of these devices that's crashing a lot, you can have a terrible experience. So, you know, a lot of our reporting is we tend to look at averages to start, and then we have to dig down and look at the actual details to make sure we aren't losing things in the average. And then we have to make decisions about, you know, how we're going to try and fix some of these things. There are thousands of devices out there. We can't get every device and we can't fix any problems. So we will go and we'll take a look in terms of how popular the device is as well. And then, you know, prioritize that with all the other kind of fixes. And then a lot of the things we also do is we, you know, try and come up with reports like this to highlight the areas where there are problems that, you know, the averages are coming out. So a lot of times we will bucket the data, you know, based upon devices or areas of the world, or maybe we will have reports that basically display data based on standard deviations and only show things that are quite a bit away from the norm. So this kind of goes to show you that people can have a radically different experience. You can't depend on the averages. And you need to really be paying attention to the details in there. Oh, and the other thing I'll also point out, doesn't really capture it, is people say, hey, you know, is this device, you know, whether it's some Samsung device, particularly in the Android world, this is very problematic. Devices that are the same on the hardware side may not be the same from our perspective. A lot of things such as the carriers can install software on there that takes up a bunch of memory. So even though we think the device is the same on the hardware level, it can have less memory available to us because the carrier has installed a bunch of software that takes up memory. In addition to these reports, we also have our crash stuff hooked up to our automated, our Slack system. So in addition to me looking at graphs, I also get messages when stuff breaks. In addition to crashes, we also want to keep track of our frame rate. If we introduce something where we've got, it brings down the frame rate. In this case, we've got a graph here. Our frame rate has been super stable. This is a slightly more interesting kind of one. You can see this is Android world. Everything is fairly stable except for this one device. So this is not super unusual, but I'd come in the morning, we take a look at this. I would look at that, we go, that's kind of strange. And we would send this off for someone to take a look at. In an ideal world, hopefully we'll have this device. If we don't, then we'll probably try and chase down, you know, is this problem consistent? How many devices are reporting it? Do we think it's a real problem? Do we think it's some sort of ghost in the machine? But this would be a first twig for us to take a look at something and say, hey, is there a larger problem here? Other things we take a look at are battery life and temperature. Battery life, obvious, because, you know, people want to be able to play our games. If our game is sucking your battery, that makes it very hard. Temperature, your device temperature. So a lot of the mobile devices, if they get too hot, the way they compensate for that is they actually throttle your GPU and your CPU so they run slower. That makes a whole lot of sense from the device perspective. Nobody wants their, you know, phone to be burning hot. And you can encounter errors if your device gets too hot. So what they do is they throttle it. The trouble is when we've got a game like ours, that's a Twitch game, that can be a terrible experience. So we basically try and design our games so they're not too hard on the GPU and CPU, and make it so that when you stop playing the game and you're back in the front end, we try and not tax the CPU and the GPU too much. The device has a chance to cool down. One of the things you take a look at is, you know, another view here on battery usage. This kind of shows that we get a lot of data back, and one of the things is in some ways we get too much data, and so, you know, we go and create a view that gives us an average but doesn't give us a lot of detail. So this is basically battery usage device for Androids, and it's just a big mess. So we get something back like this. It's not useful. We look on the iOS, it's a bit easier to parse out because it's your devices. So what we would do is, in this case, if we get reports back, we would only, run the report on certain devices. So you're always kind of trying to take two views at it. Is like, hey, what's happening on the average and what's happening with these specific devices? And we spend a lot of time doing this, looking at the micro and the macro views of all the different data. The other place that we get stability and crash reports from is from the first parties, from Google and Apple. In this case, this is a sample of the crash reports we get from Google. The top left one is the crash rate. And the interesting thing there is they have this orange line, which is the bad behavior threshold. So we don't want to cross the bad behavior threshold. Well, ideally, we don't want to have any crashes at all, but we want to make sure we stay below the bad behavior threshold, because if you cross that, there is a chance that you can be penalized. And that typically would mean lower search rankings in the stores, which can really impact the number of people playing your game. They also provide information on things that sometimes we can't get. In the case of excessive wake-ups, that's basically our game asking for attention, and basically being asked to be put to the forefront. ANR, that's application not responding. So in this case, the OS has told our game to wake up for some reason because the users probably switched to it and we don't respond. And these are stuck partial wake locks. So somebody has basically, again, asked us to come up and we are locked and not coming back up. So there's a variety of information we can get from the first parties. And they also track and monitor our games as well to make sure that we're performing well. We also take a lot of information on our servers. Server crashes, typically that's handled by we have a DevOps group. So if the actual server is crashing at the OS level, they'll look into that. We track server performance. Servers that are under high load usually is an indication that's an early indication that something's going wrong with our systems. Server application crashes. So this is our game crashing on the server. We're interested in that. And there are many different kind of servers we have running our game, particularly with nwRock, which I'm most familiar with. Is we have a matchmaking server. We have what we call our Sparks application server. And that's basically it's a RESTful API server that's used to store and retrieve all the player data. We have our gameplay server. nwRock is a server authoritative that we used to download updated localization data. We can run without that one, but the localization may not be the most recent ones we have if that server is not running. So we track all that. And again, a variety of different graphs. So in this case, this is our matchmaking duration. If our matchmaking duration starts to go up, usually that's a sign something may be going wrong. We have to be careful with this one because matchmaking duration, this is how long it takes. Matchmaking duration in this case is how long it takes someone to find a match. This can also change depending on how many users are playing and the time of day. But this is usually an early leading indicator something's going bad. This is actually, once you've made a match, this is actually our game creation time. So we say, hey, we found a match. How long does it actually take to spawn a game? This is a great one because if we're slow to spawn games, we can fall behind. And you can actually take a look at this one, this graph. Our network engineer called it mean matchmaking time, and we had a big bun fight about whether this was matchmaking time or matchmaking creation or game creation time. And there's a lot of discussion because we thought this was confusing. But the guy who made the graph disagreed. But this is game creation time in my world, and he calls it matchmaking time. So again, another thing that we track on a daily basis. This ends up on a Grafana dashboard, and typically we look at that first thing in the morning as well. These are game server errors. So as I mentioned, our game logic runs in a server for nwRock. So we track this, the number of errors that are happening every day. In this case, the number of distinct errors and the number of reported errors that are coming through. And this is another view on our game server errors. It's called GLOW, which is an acronym for Game Live Over Wire. So we have two kind of things. So we have reported errors, i.e. I've noticed there's a problem that shouldn't be happening. And then the yellow bar is actual crashes where that game server has crashed. So the people playing on that instance of that game have lost their connection. So they will not be able to restart that game. because the server has crashed. So there are tons of things we have to track. And again, one of the things we have automation. So I get pinged on Slack if we start seeing crashes. We have some logic in there. Usually we tweak it because we don't want to get pinged every time there's a crash. We try to basically say, is there an increase in the number of crashes? And if there is, start alerting people. The other thing we want to take a look at is our login servers. So this is basically tracking the number of logins we're having. In this graph, everything is looking good. The interesting thing about the login servers is we have Kabam IDs. So we have shared login servers that all of our games use. And then there are also Apple and Android authentication servers. So it's not just our server. So in this case, this example here, you can see that it looks like we're going fine about halfway through the graph on the top. And then the light blue line starts to peak, and those are failed logins. So we are having failed logins for some reason. When this typically happens, if I was to see this graph come up, I would look at this and I'd say, hey, my first question is it happening on Android and iOS? If it's happening on both platforms, it's probably a Kabam login ID issue. If it's only happening on one platform, that's only happening in iOS. You can go, there are various web pages you go take a look at the status of their login services. So it's probably one of their problems. If it turns out it's happening on both platforms, it looks like a Kabam thing, I will then go take a look at our other games to see how they're doing. If all of our games are having login problems, it's probably a problem with our central login server. And I will contact our central technology group. If it's only happening in my game, then it's on my plate, and I'll start digging it up. So yeah, those are the kind of things we have to track. So it's kind of interesting. A lot of the things, the first thing I come in the morning is spend a lot of time. I usually spend at least 10 or 15 minutes kind of looking at this and see how things are going on the games. And is their game stable, and are our customers happy? Summary, plans for stability and start early. It's really hard to catch up later, and it's really hard to figure out where you are when you're trying to make the game stable if you're starting and you're behind. Automated testing, CI/CD is all super great. And you want to scale up your investments in that as your team gets larger. If you've got a team of 2 people, your investment in that can probably be low. If you have a team of 100 people, some of our team sizes are, you need much more automated infrastructure. You can't keep up with it manually. So you need to invest in it. Telemetry in a live game is crucial. You need to know what's going on with your game. You can't depend upon, people calling into your helpline and things like that. The scale of the data and the different varieties across the world are just too huge. And you're never going to be finished. Your game will never be stable. You'll never be done. Your game is always going to change, and the world is going to change. So it's an ongoing investment. So you should be prepared for it. And that's it. That's the end. Do people have any questions or comments or jokes?
Yeah, so feel free to put in the chat if you have any questions, or you can join us on video here as well. Just a couple of things that came in. Edmund, yes, our Kabam homepage is really cool. You can play around with it a little bit. If you like that, of course, that our other social media pages you'll like even more. So check that out. And yes, Melvin, we can also, part of our day-to-day sometimes means playing games on the SkyTrain. So pretty interesting there. Yeah, do we have any other questions?
Hi, is it all right if I ask an audio question?
Of course.
This may be an easy one to answer. Can you hear me?
Yep.
So I'm guessing most of your games are made through the Unity platform, and do you have your own platform that you have for other games?
So yes, all of our games are Unity games. We do some things our own, particularly we have our own rendering library. So visuals are super important in our game. So we do not use the base rendering libraries that come with Unity. And then we have a whole bunch of other things that we basically supplement with. So there is a Fuse, our client library called Fuse, which does all sorts of things, such as memory management, asset management, and things like that, localization. And then we have a huge client server library called Sparks that does things like login, user management, gear management, RPG data. It allows us to tune data live, allows us to do all sorts of stuff like that. So we use Unity and a whole bunch of homegrown tech to build our games.
Awesome, thanks.
And whenever we have to upgrade the Unity libraries, that's usually a huge stability problem as well too. We try to balance between being on the newest Unity stuff, because if we ever have a problem with Unity, the first thing that Unity tells us is, are you on the latest version? And if the answer is no, they try to get us to upgrade. It's usually a fair bit of work for us to upgrade as well.
So it's kind of a two-part question as well, but does that also mean that you would have to take the servers down if, say, you would have to update a part of the Unity for a game?
Hopefully not. I mean, most of our servers, it depends. So in our world, particularly the game I worked on at nwHacks is, we spend most of our time talking to two kinds of servers. So there's our Sparks servers, and those typically store all the player data, what sort of equipment you have, where you are in your RPG progression, and we connect to those servers over a RESTful API. So that's fairly agnostic to what version of Unity we are running. So if we are we're doing a bad job as engineers if we're sending Unity versioning information over that API. That means we've done a poor job. So typically not. We run on nwHacks, we run our game logic on the servers as well too, and that is run in C#, but a mono, but is not run inside of Unity. So sometimes the answer is sometimes we have to do that because we have to keep our game client versions of C# in sync with what we're doing on the server. Usually we don't have to, but it's usually easier if they start to drift too far apart. But again, we really try to avoid coupling those together. Myself and the other people, we all, we're not doing a good job as engineers if upgrading our client causes us to upgrade our server. There should be on the APIs, we should be able to basically keep those separated. And if we're not, then we usually yell at each other or whoever did it.
Okay, great. Well, thanks so much for your time, Tim. I know we're at time here as well for nwHacks, but of course we're on LinkedIn, or you can send us an email. A lot of us will also be here during the post-hackathon booth tomorrow. So if you need any questions for us or questions for Tim that we can relay on to him, please let us know. But yeah, super excited to be part of nwHacks again this year. And
all right, appreciate everyone coming out. Bye.
Thank you. Have a good night.